many fingers does a machine have to take before someone installs a guard? I went looking for the answer in the Bureau of Labor Statistics records, in the OSHA Enforcement Archive, in the medical literature going back over 100 years, and what I found was not a number. It was a medical paper, published in June 1912 by a surgeon named Alfred H. Noeren, practicing in Buffalo, New York. Over a period of 3 years, from January 1909 to March 1912, Dr. Noeren treated 35 patients who had come to him with traumatic finger amputations sustained in industrial accidents. 55 fingers total, in 35 different hands, in 3 years, in one city, treated by one surgeon at one hospital, and the majority, Noeren wrote, had their fingers caught in stamping machines powerful enough to go through a steel plate, cutting off the fingers with little injury to the remainder of the hand. Cutting off the fingers with little injury to the remainder of the hand. That is the clinical description of a machine that operates so fast and with so much force that it severs the fingers cleanly, the way a guillotine blade drops, leaving the hand structurally intact and the fingers gone. The hand survives, the fingers do not. The man goes home with a bandage where his livelihood used to be, and the machine does not pause between cycles. And tomorrow morning someone else will stand where he stood and put his hands where he put his hands and feed the next blank into the same die. This video is not about an explosion. It is not about a single disaster that killed dozens of men on a single morning. It is about the machine that killed and maimed more American factory workers than any other single device in the history of American manufacturing. And it did it one hand at a time, in every stamping plant, every sheet metal shop, every auto parts factory, every appliance manufacturer, every hardware company, in every industrial city in the United States, for over 100 years, without producing a single headline large enough to force a change. The machine is the mechanical power press, and it has been the #1 cause of workplace amputation in the United States since the Bureau of Labor Statistics began tracking the category. It is still causing amputations today. In 1997, the Occupational Safety and Health Administration calculated that power presses were responsible for approximately 650 amputations per year in American workplaces. 650 per year. Nearly half of all injuries involving mechanical power presses resulted in an amputation. According to Bureau of Labor Statistics data from the same period, approximately 60% of all work-related amputations involved a worker's finger or arm getting caught or compressed by a press or similar machine such as a conveyor. The power press was not merely the leading cause of industrial amputation, it was the category. Before the regulations, before OSHA existed, before anyone was counting at the federal level, the amputations were happening at rates that nobody documented and nobody aggregated and nobody presented to a legislature or a commission because the injuries were too common and too small and too quiet to attract attention. A man lost 2 fingers on a Tuesday in a stamping plant in Cleveland. Another man lost 3 on a Wednesday in a sheet metal shop in Detroit. Another lost his thumb on a Friday in a hardware factory in Bridgeport. None of them made the newspaper. None of them prompted an investigation. None of them counted toward anything except the company's workers' compensation premiums. And even those costs were absorbed into the operating budget as a predictable expense. The cost of fingers was built into the price of the product. I need to explain how a power press works, because the danger is in the cycle, and the cycle is everything. A mechanical power press uses a motor-driven flywheel to store kinetic energy and release it in a single controlled stroke. The motor runs continuously, spinning a heavy flywheel to operating speed. When the operator activates the press, a clutch engages the flywheel to a crankshaft. The crankshaft converts the rotational energy into linear motion, driving a heavy metal slide called the ram downward onto a die, a shaped metal tool bolted to the press bed. Between the ram and the die is the point of operation. That is where the work happens. That is where the danger lives. The operator places a piece of sheet metal or a blank or a pre-formed part onto the lower die. He positions it by hand, he adjusts it by hand. His fingers are in the die space, inches from the lower die surface, touching the workpiece, lining it. Then he activates the press. On a foot-operated press, he steps on a pedal mounted at the base of the machine. On a hand-operated press, he pulls a lever or depresses a palm button. The clutch engages. The ram descends. The upper die meets the lower die with a force that ranges from 5 tons on a small bench press to 200 tons or more on a production floor press used in automotive stamping. The metal between the dies is stamped, punched, formed, bent, sheared, pierced, drawn, or blanked into the desired shape. The ram retracts. The cycle is complete. The operator removes the finished piece and reaches back into the die space with the next blank. The cycle time, from the moment the ram begins to descend to the moment it returns to its starting position, is less than 1 second on most production presses. Some cycle in half a second, some in a quarter of a second. The fastest production presses cycle at rates of 100 or more strokes per minute in continuous mode. The human reaction time to an unexpected visual or tactile stimulus is approximately 200 to 300 milliseconds. On a press that completes its full stroke in 250 milliseconds, the ram has already closed before the brain has finished registering that something is wrong. The operator cannot pull his hand back. The physics will not allow it. The machine is faster than the nerve impulse. The foot pedal was the most dangerous activation method, and it was the most common. A foot pedal sits on the floor at the base of the press. The operator steps on it to trip the clutch. The problem is that a foot pedal can be depressed accidentally. A worker shifts his weight. A worker steps forward to reach a blank that has not seated properly in the die. A worker bumps the pedal with the toe of his boot while both hands are in the die space adjusting a workpiece. One misplaced step, one inadvertent pressure, a fraction of a pound on the pedal, and the clutch engages, the ram descends, and the hand that is still in the die receives the same 200 tons of force that the steel plate was supposed to receive. In repeat mode, which was standard on most production presses, the press cycled continuously as long as the foot pedal was held down. The ram went up, came down, went up, came down, in an unbroken rhythm determined by the flywheel speed. The operator's job was to feed blanks into the die at a rate that matched the machine's cycle. Reach in, place the blank, pull the hand back, let the ram descend, reach in, remove the part, place the next blank, pull the hand back. Over and over for hours, for an entire shift, for every shift, 5 or 6 days a week. The rhythm became automatic. The hands moved without conscious direction. The operator stopped thinking about the timing because thinking about the timing slowed the rhythm, and slowing the rhythm slowed the line, and slowing the line was not acceptable. The hands moved on muscle memory. Muscle memory does not account for the blank that jams, for the piece that shifts, for the fraction of a second in which the operator reaches back in to adjust while the ram is already descending because his foot is still on the pedal and his body has forgotten to lift it. That is how the press took fingers, not through malice, not through malfunction, through rhythm. The operator's body synchronized with the machine, and the synchronization was the danger. The danger was built into the job, and the job was the same in every factory in the country. Nobody installed the guard that would have broken the synchronization and kept the hand out of the die, because the guard slowed the rhythm, and the rhythm was the production rate, and the production rate was the money. If your grandfather worked in a stamping plant or a sheet metal shop or an auto parts factory, if he came home with fingers missing and never talked about how it happened, if you grew up seeing his hand wrapped around a coffee cup and wondering why it looked different from yours. This is the machine. Subscribe if you want to see what else is buried in the records. The guard existed. I need to say this clearly because the history of the power press is not the story of a machine that could not be made safe. It is the story of a machine that was not made safe because making it safe cost production time. A point of operation guard is any device that prevents the operator's hands from entering the die space while the press is cycling. The simplest and oldest version is a physical barrier guard, a metal or plastic enclosure surrounding the die that the operator cannot reach through, over, under, or around. The barrier guard was available before 1900. It required no electricity, and it required no electronics. It was a box around the die, and it worked. More sophisticated versions followed. Two-hand controls required the operator to press and hold 2 buttons simultaneously. one with each hand, throughout the entire stroke cycle, ensuring both hands were on the controls and physically removed from the die space when the ram descended. 2-hand controls were in use in European factories before the First World War. Pullback devices used wristbands attached to cables that physically retracted the operator's hands from the die space as the ram began its downstroke. The operator's hands were literally pulled out of the danger zone by the machine itself. Sweep guards used a mechanical arm to physically push the operator's hands away from the die before the ram closed. Light curtains, developed in the 1940s and commercially available by the 1950s, projected an array of infrared beams across the opening of the die space and stopped the press instantaneously if any object, including a human hand, broke the beam. Every one of these technologies was available and proven before 1960. The barrier guard before 1900, the 2-hand control before 1915, the pullback device before 1930, the light curtain before 1955. The technology to prevent power press amputations existed for decades, in some cases for half a century or more, before any law required its use. It was not required because it cost production speed. A barrier guard adds time to every cycle because the operator must work around the enclosure to load and unload the die. A 2-hand control eliminates the foot pedal, which is the most dangerous trigger, but it also eliminates the operator's ability to handle the workpiece with both hands during loading, which requires either a fixture or a redesign of the workflow. A pullback device restricts the operator's range of motion and requires adjustment for each operator's arm length and working position. A light curtain can trigger false positives, halting the press, and requiring a manual reset that interrupts the production cycle. The industry consensus, widely cited in manufacturing trade publications throughout the mid-20th century, was that point-of-operation guarding reduced production throughput by approximately 10 to 15%. For a stamping plant running 3 shifts, producing thousands of parts per day on dozens of presses, a 15% reduction in throughput was a significant financial cost. The calculation was simple. Guards cost production. Production was revenue. Revenue was the priority. The workers' hands were the variable that absorbed the difference. Massachusetts passed the first factory inspection law in 1877, the same year this channel covered the beginning of the Bessemer rail expansion. The law required factory owners to place guards between workers and machinery and to provide protection on elevators and fire exits. Other states followed through the progressive era, but the laws were inconsistently enforced, narrowly interpreted, and widely ignored in practice. The American National Standards Institute published its first standard for power press safety in 1937, ANSI B 11.1, establishing specifications for guard design and installation. But compliance with ANSI standards is voluntary. There is no legal penalty for ignoring a voluntary standard. There was no federal requirement for point-of-operation guarding on mechanical power presses until the Occupational Safety and Health Act of 1970 created OSHA. In 1971, OSHA issued Standard 1910-21 which made it the responsibility of the employer to provide and ensure the use of point-of-operation guards or properly applied and adjusted point-of-operation devices on every operation performed on a mechanical power press. 1971 marked the federal requirement for guards on the machine that had been taking fingers since before the Civil War. That requirement arrived nearly a full century after the first state law, more than half a century after the barrier guard was commercially available, and more than 3 decades after ANSI published its first voluntary standard. Between 1877 and 1971, presses operated across America with no consistent federal requirement to install the device that would have prevented the majority of the amputations they produced. And even after 1971, the amputations continued. Requiring a guard by law is not the same as installing a guard on a press. And installing a guard on a press is not the same as keeping the guard on the press. Employers removed guards, they modified them, they relocated them to positions where they could not function, they rendered them dysfunctional or inaccessible. In California, the problem became so severe that the legislature carved a special exception into the workers' compensation system. Under California Labor Code, Section 4558, known as the power press exception, a worker injured by a power press from which a point of operation guard has been removed by the employer can sue the employer directly in civil court, bypassing the normal workers' compensation limitation on lawsuits. The law was enacted specifically because employers were removing guards so frequently and the resulting injuries were so severe that the legislature concluded the normal compensation system was insufficient to deter the practice. The legislature was free to assume, wrote the Court of Appeal, that the need for protection was most evident in the case of power presses which utilized dies. The legislature could properly conclude that those machines uniformly present a serious danger to workers when point of operation guards are removed, because they uniformly employ a powerful pressing or stamping motion which can cause serious crush injuries. Uniformly present a serious danger. That is a court of law describing the machine that was, at the time of the ruling, sitting in every stamping plant and sheet metal shop and auto parts factory in the state of California. Most of them had guards installed, some had guards removed, and all of them were waiting for the next hand that would enter the die at the wrong moment. In January 2015, in Wellington, Ohio, a 23-year-old man was operating a mechanical power press at a metal stamping company called Wellington Stamping, a subsidiary of Shiloh Industries. He was clearing a machine jam. A jam is the moment of greatest danger on a power press because clearing it requires the operator to reach into the die space while the machine is stopped but still energized, still capable of cycling if the clutch engages or the foot pedal is depressed or the control system malfunctions. The press at Wellington Stamping lacked adequate point of operation guards. The young man's right hand was crushed in the die. He lost his right pointer finger, his middle finger, and his ring finger. OSHA investigated. Inspectors found that the company had not trained the worker on safely operating the mechanical press. The press lacked adequate safety mechanisms. The company had not implemented energy control procedures, known as lockout-tagout, to prevent the machine from activating unexpectedly during the jam clearing procedure. 7 serious violations were issued. The proposed penalties totaled $49,000. The incident was reported to OSHA under new self-reporting requirements that had taken effect on January 1st of that year, requiring employers to report amputation injuries within 24 hours. Before those requirements, the company would not have been required to report the amputation at all unless it resulted in the worker's hospitalization. 3 fingers, $49,000 in proposed fines, 7 violations. The guard was available. The guard was required by federal law. The guard was not installed. The man lost 3 fingers on his dominant hand at the age of 23. The company paid less than $50,000 in penalties. The press kept running. OSHA's acting administrator at the time, Greg Watchman, said in the agency's press release, something I keep returning to: operating a mechanical power press can be extremely dangerous. Yet injuries are preventable when employers ensure that guards, which have long been required and are readily available, are installed and maintained on presses in order to protect workers against the punching action of metal stamping equipment. Long been required, readily available, installed, and maintained. Every word in that sentence is a confession. The agency responsible for protecting American workers was acknowledging, in its own official communication, that the technology to prevent the injury had existed for decades, that the law requiring its use had been on the books for decades, and that the employer had chosen not to comply with either. The press release does not say why the guard was missing. It does not need to say why. The guard slows the line. The line is the money. The man's hand is the cost. Crystal Eastman, in the Pittsburgh survey of 1907 and 1908, the same study I cited in the Butler-Ladle script, counted the human wreckage of the industrial era in a single year in a single metropolitan area. She found 45 one-legged men, 100 hopeless cripples walking with crutch or cane, 45 men with a twisted, useless arm, 30 men with an empty sleeve, 20 men with but one hand, 60 with half a hand gone, 70 one-eyed men. She did not separate her data by machine type, But the mechanical power press was in every factory she entered, in every foundry, in every stamping operation, in every metalworking shop in the Pittsburgh Industrial District. And the men with half a hand gone were, in large proportion, its products. They were the men who had fed blanks into a die at the rate of 100 strokes per minute, and pulled their hands back 99 times, and failed to pull back on the 100th. Eastman wrote that it is no wonder that, to a stranger, Pittsburgh's streets are sad. The power press is still in use today. It is in every automotive stamping plant in Michigan and Ohio and Indiana and Tennessee. It is in every appliance factory, every sheet metal shop, every hardware manufacturer. It is in the plants that make the parts for the cars you drive, and the washing machines in your laundry room, and the electrical panels in your house, and the steel cabinets in your office. The presses are faster now. The controls are more sophisticated. The guards, when installed and properly maintained, and not removed or bypassed or rendered inaccessible by an employer who's decided that the guard slows the line, are effective. Light curtains can halt a press in milliseconds. Two-hand controls can prevent accidental foot pedal activation entirely. Presence sensing devices can detect a hand in the die space and stop the ram before it closes. The technology works. The technology has worked for decades. The question was never whether the guard could prevent the amputation. The question was whether the company would install it, and the answer, for over 100 years, was not if it slowed the line by 15%. 18,000 amputations, lacerations, crush injuries, and abrasions per year from machinery in American workplaces. That is the current OSHA estimate. Each year, more than 200,000 American workers suffer injuries from operating parts of dangerous machinery. The power press remains the single largest contributor to the amputation subcategory. Machine guarding violations remain among the most frequently cited OSHA infractions every single year. The same violation, the same machine, the same missing guard, the same result. Year after year after year, every other machine on this channel killed in a single event. The Bessemer converter produced a rail that cracked under a train. The lap joint boiler hit a crack between two plates that blew a shoe factory apart. The dam failed on a foundation nobody tested. The caisson dissolved nitrogen into the blood of men who came up too fast. The ventilation furnace was turned off to save fuel, and 216 men walked into the gas. The powder press compressed its own ignition source. The missile silo had one ladder and no backup power. Each of those machines produced a disaster, a body count, a headline, an investigation, a reform. The power press never did that. The power press never exploded. It never collapsed. It never failed catastrophically. It did not need to. It took one hand at a time, one finger at a time, one shift at a time, one factory at a time, in every industrial city in the country, for over a century. And because it never killed 50 people in a single morning, because no photographer ever captured the aftermath, because no governor ever convened a commission, because the injuries were too small and too common and too quiet to generate the outrage that produces change, the press ran without a guard for 100 years while the guard sat on a shelf in a supply room gathering dust. The guard was available. The guard was proven. The guard was not installed. And somewhere in America right now, today as you listen to this, a man is standing at a mechanical power press with a foot pedal at his boot, a die at his fingertips, and a ram above him that will cycle in less than a second with 200 tons of force. The guard is not there because the guard slows the line by 15%, and the line is the money, and his hand is still in the die. I started with a medical paper. Dr. Alfred H. Noren, Buffalo, New York, June 1912. 55 fingers in 35 hands in 3 years from one type of machine. The majority had their fingers caught in stamping machines powerful enough to go through a steel plate. The men had oil and soot and dust on their hands. The fingers were removed under local anesthesia in the doctor's office, 2 at a time, because 3 was considered more pain and ordeal than could reasonably be asked. That paper was published in 1912. In 2015, 103 years later, a 23-year-old man in Ohio lost 3 fingers in the same type of machine because the guard that had been available for over a century was not installed. Same machine, same injury, same missing guard, Same calculation, same answer. America wasn't built in boardrooms. It was built in the dark, inside furnaces under 40-ton weights, and sometimes at a stamping press on a factory floor, where the ram came down in less than a second and the guard was on a shelf in a supply room and the man's hand was in the die, and nobody had installed the one piece of equipment that would have kept it out, because the equipment slowed the line, and the line was the money, and the hand was the cost. There are more of these stories. More machines, more furnaces, more men who went into the dark and came out different or did not come out at all. Subscribe if you want to see what I pull from the records next. If you want to see how a welding rod in a missile silo killed 53 men because the only way out was a single ladder in the dark, that video is on screen now.